All right, I think we are ready to get started here. Welcome, everyone, to the fifth session of Office Hours. For those of you who have never joined one of these before, this is a monthly live stream where we get live and answer questions directly from you all, our users, and we demo new features and just try to make sure that you have everything that you need to get better at all things gateways, ingress, and traffic management. I'm Joel. I'm a developer educator here at ngrok. And today we're doing things a little different. I'm joined by a special guest, as I think you all are aware, the founder and CEO of ngrok, Alan. Alan, why don't you take a minute to introduce yourself and then we'll jump right in.
Uh, Hi everyone. So glad to have you all here. My name's Alan Shreve. I'm the CEO and founder of ngrok. I'm inconceivable on the internet and really excited to be here and show you some of the things that we've built over the last year.
Yeah, and on that note, I joined ngrok in roughly the middle of 2024, so been 6 or 7 months now. And I saw an enormous amount of change happening within the product, within even just that the latter half of 2024, those 6 months. And there was a plenty before that, that, I kind of learned about once I started here. So without getting too into the technical details yet, because I know you're going to do a demo and walk us through all of these primitives and how to set them up. I'm just curious about what were some of the bigger business drivers or product related drivers that led to all of this change that you will get into in just a couple minutes.
Yeah, at the beginning of 2024, we announced and really launched that ngrok was going to become suitable for use as a production API gateway. And it's been part of ngrok's vision all along to improve the speed of development on the internet, to make it easier to build and deliver new applications. And we had many customer requests, our own requirements as well, about how to bring more advanced traffic management and capability to the ngrok platform. And that really started us off on this journey of building all of the production-ready API gateway functionality into ngrok, the platform. And so I'll talk a little bit more about that as we get into it, but that involved some pretty exciting changes that not only are useful for building applications with ngrok serving as an API gateway, but really ngrok, these primitives being useful to all ngrok users across all use cases, whether you're doing local development or connecting to, services in other customers' networks or running it on your IoT device, anything like that.
Yeah, amazing. Awesome. So what we're gonna do is we'll have you kind of jump into your demo. I'm hearing kind of in the background here that our chat is not currently up and running. Not sure why that's happening, but it looks like the Q&A section is running. So there's a couple questions in there already. So folks, if you have questions about the things that Alan is going to demo or the roadmap things that we're going to talk about in the future, please feel to do that there for now until we can try to get the chat going as well, and get some questions there as well. So yeah, I know you could go into tons of detail about like what ngrok looks like before and why we're getting rid of some of those things, but I think the demo that you have planned is a great way to kind of like forget about all that stuff and look forward and see what these pieces are. And yeah, happy to let you kind of kick things off when you're ready.
Let's do it. I'm going to start with a couple of slides just to give folks a little bit of an intro here. Let me get that set up here. Um, so like I said, welcome everyone. It's great to be here and to have you all here. I want to talk a little bit about that journey that I just mentioned for around ngrok building out our capabilities as an API gateway. And we came into 2024 with a number of features that we built for ngrok being production ready. Uh, and there are many that may use any of these features on the platform. When you're creating endpoints and accepting traffic with ngrok, we automatically manage your TLS certificates. We globally accelerate your TLS termination and traffic by using our global network and the many points of presence that we run around the world. We automatically protect your applications from DDoS attacks. We have observability primitives that allow you to export logs of ngrok traffic out to logging providers like CloudWatch Logs or Datadog or Azure Monitor. And then we added support for being natively integrated with Kubernetes, which is how we run our internal systems and how many of you run your cloud services as well, to support both the ingress and gateway API specifications to allow you to create ngrok endpoints via a Kubernetes operator. But what we found after all of those things was that we really still weren't in a place where we were ready to be an API gateway for applications. And what that really meant was that we had to rebuild some of ngrok's pieces from the ground up. And we took a fresh look at a number of our primitives, things like edges and tunnels that were confusing to users and were inflexible and not allowing us to create the expressiveness that's really needed for an API gateway and the traffic that you want to handle through it. And we introduced a number of new primitives into the platform that I'm going to talk to you about right now to address those problems. Uh, Ultimately, what it boils down to is that ngrok's product surface at this point is very much focused around two primary concepts. One is endpoints and the way that you control traffic through them, which is traffic policy. And we've always had the concept of endpoints in the platform. That's not really new. Many of you would think of them as tunnels, but endpoints are essentially a URL, right? A way to accept traffic. That's what we think of as an endpoint. And we introduced two new types of endpoints and a way to manipulate traffic through them that is much simpler than what we were using before. So what I want to talk to you about first is traffic policy, which is a new system that we've added to allow you to manipulate the traffic that transits through ngrok. It is a powerful configuration language that offers the ability to filter, match, orchestrate traffic exactly as you need. And it enables you to validate incoming traffic, block malicious traffic, rewrite URLs, respond with custom content, forward your traffic or route traffic to different, essentially like upstreams or origins, based on any kind of condition that you might want to dream up. We have a number of ways to number of variables that you can use to route and manipulate the traffic. It's a really simple YAML structure. It's a rules-based system, and it uses Google's Common Expression Language, CEL, for conditional execution of rules. And we'll demo this in just a moment. The second thing we introduced is cloud endpoints. Cloud endpoints solve a problem where a number of developers have used ngrok and said, have had the problem of needing an endpoint to be online, even when the machine that they had started the ngrok agent on had gone offline. And so we introduced a new concept that we call cloud endpoints, which are persistent, always-on endpoints. Their creation and deletion is, and configuration updating is all managed centrally via the dashboard or API, unlike agent endpoints, which are created from your terminal with the agent or our SDKs. These are created and managed centrally. They don't forward traffic to agents by default. Instead, they use our new traffic policy system to control how their traffic is responded to, routed, including sending that traffic to upstreams that are run by what we now call agent endpoints. And the last one is this concept of internal endpoints or internal bindings. Up until now, every endpoint that you've used in ngrok has been public. It has a public URL that is addressable to the world. And we've added the new ability to create ngrok endpoints that are not public, that exist only within your ngrok account. They are secure, non-public endpoints. They make it possible to connect an application to ngrok without making it addressable on the internet. Instead, the way that you receive traffic to them is to forward traffic from another public endpoint to them. So we'll dive in and I'll show you what all of this looks like now. But before I do that, I want to tell you that all of this is stuff that we are already using ourselves. So when you go to ngrok.com or api.ngrok.com or dashboard.ngrok.com, all of that is running through ngrok. We have replaced all of our load balancers, reverse proxies, API gateways with ngrok itself for all of our public properties here. Without further ado, I'd love to see it in action. So let's do that. I'm missing. No, I do have it up here. Great. Let me delete this. Okay. So what we're going to demo here is cloud endpoints, internal endpoints, and traffic policy. I'm going to start with just a simple ngrok endpoint that is running. I've got two different locations where I'm going to run this, one being in AWS and the other being in Azure. Technically, they are both running on my local machine, but really for the purposes of ngrok, ngrok runs anywhere, and so you can imagine both of them in different cloud services. I've got here just a very simple index.html file in this directory that we're going to serve. And we're going to start with just the usual way that you've used ngrok before, which is to put an application online. I'm going to put it on my domain here, which is incontrollable.ngrok.app. And normally, I think many of you are used to forwarding to a local port, which is how you usually use ngrok. Just for demo purposes, ngrok has the ability to forward to a directory. And so I'm going to have it forward to this current directory by giving it a file URL, which will serve that file that we have here, right? That says it's AWS. So let's run this command. Oh no, live demos. They're always causing problems here. Let's see. It doesn't look like anything else is online here. All right, well, we're going to try a different name then. And I think to do this, I'm going to need to grab myself another domain. Let's grab that one. And we'll go back here. All right, so we're off to the races here. We're running our endpoint here. And if we access it in our web browser, you can see it says it's AWS. These demos are, of course, live. So if you do want to access any of the URLs while it's happening, you are, of course, welcome to. But yeah, that's a normal invocation of ngrok that I think many of you have all seen before. What I want to take you into now is the new capabilities here. So I want to show you what this traffic policy system is that we're talking about. Traffic policy is a simple YAML rules language to define how to run or how to manipulate traffic that runs through ngrok. So this is an example of one of those traffic policy definitions. Traffic policies are made up of phases, which you can think of as events that happen in the life cycle of handling a request or connection. This particular policy has a single phase, which is on HTTP request, which will trigger every single time an HTTP request comes through the endpoint that this traffic policy is applied to. Inside of a phase, you can specify one or more sequential rules to be executed. This particular policy has a single rule, and that single rule has a single action that it takes, which is to enforce rate limiting, a really common behavior that you want in front of your APIs and web applications. And so when you run this traffic policy, it will begin rate limiting HTTP requests through it. It will rate limit each client IP address to 5 requests per 60 seconds here. This is the configuration for the rate limit action. So the way that we would apply it is we would take our existing ngrok endpoint that we created before and simply add a new command line flag, which is traffic policy file, and run that. And when we refresh over here, you'll see that we're starting to get requests. And after a few of them, we start getting 429 errors because the rate limiter has kicked in that we have made too many requests to this endpoint within that window. And so now the requests are being rate limited. And if we wait long enough, we will eventually turn over the rate limit and we will be able to make requests again. But we're not going to wait 60 seconds for that. So that's what the traffic policy file looks like. Now I want to show you a little bit more about how we can make them more complex. This is a traffic policy file that has 2 rules. The rule below here, this is the one we already had, so we're just introducing this new rule in front of it. And what this new rule adds is this expressions keyword, which you can really think of as conditions under which the rule executes. So the action that we're going to execute if we match this condition is to return a 200 response, which says we're debugging. And the condition under which we're going to do it is if the query parameter in our URL has the value 1 for the key for the parameter debug. So let's start that off here. And we're running this again, so you can see that we're back to its AWS here. But if we add debug equals 1, you can see that it says we're debugging now. If we go over to the ngrok dashboard and look at our endpoints tab, you can see all of your endpoints that are online, including this one that we're running here. And if we click into it, we can actually see the traffic policy that was applied. So it's really easy to see now when you have your endpoints online exactly what and how they process the traffic that is going through them. You can see here, as we get to cloud endpoints later, that these traffic policies are read-only in the dashboard, and that is because the agent is authoritative about the traffic policy that it defines on the endpoint that it creates. All right. Let's take a look at a little more complicated of a traffic policy here and introduce a new concept. All we've changed here, everything about this traffic policy is the same, except for this content piece of what we render when we say debug equals 1. And what we're showing off here is that the debugging, or rather the actions that you can apply here, so this particular action is the custom response action, can actually be made dynamic by customizing, by essentially templating the variables that we have available for these cell expressions into the configuration for the actions themselves. So there are any number of variables that you have access to when you use ngrok's traffic policy engine. They can be used both to define when a certain rule applies via this expressions keyword, but they can also be templated into the configuration of your actions to make them dynamic and change based on the request that comes in. So let's apply this third traffic policy file and go back over here and run it again with debug equals 1. And you'll see that our response has changed here, which shows you my current browser version and the TLS version that I've negotiated, as well as the path that was accessed. So if we change the path to office hours, for instance, you'll see that the path becomes office hours in this response here. This last little bit here is also interesting, which shows you that, whoops, one, shows you that when we click into it, even these things that you template in, oops, let me scroll back over here, they are not just the variables, they are actually full cell expressions. So you can actually evaluate out not just necessarily the value of a variable, but something that is conditional or transformation of a set of variables into these action configurations. If you go over to our docs, we have a whole section on traffic policy. The place to look for what you can manipulate is under the variables section. The ones that are typically the most interesting are the HTTP request variables, which give you access to all of the things that you might want to use inside of your traffic policy. Inside of HTTP requests, things like cookies and content types, everything about the URL, including its host and port and authority. All of the headers that are available in the request as well can all be used to switch and change behavior using the traffic policy engine. There are many, many more variables than just the request ones. There are also variables about which endpoint you are running on in case you want to make traffic policies that are agnostic and can be applied to many different endpoints, as well as variables about the connection itself, including things like the TLS version and cipher suites that were negotiated, all the way to geocoding that we do to tell you where the traffic is coming from in the world. Uh, the last thing I'll show you here is that traffic policy also has another, like I said, on HTTP request is just one phase, but we also have other phases. There are two other ones. One is for on TCP connect, which I'm not showing here. And the one that I'm showing here is on HTTP response, which applies after the upstream service has responded. You can then manipulate the response before it is returned back to the client. So in this particular example, we're checking to see if the connection's TLS version is less than 3 or 1.3, and if so, adding a header with a deprecation warning. So things like that. Yeah, allow you to essentially manipulate traffic essentially on the way in and on the way out. Next, I want to take you over to cloud endpoints. So we talked about these are endpoints, right? The ones that we've been creating so far here, we call agent endpoints, and they are, you can see in the message in here, they are what most of you have used to think of as ngrok tunnels. We now think of as agent endpoints. But if we take a look at the dashboard here, right, this agent endpoint is online, but if I kill that process, the endpoint goes offline. We have introduced a new concept, which are these cloud endpoints, which allow you to create persistent, always online endpoints. So we're going to create a cloud endpoint here. And this one that we've created is incontrollable.ngrok.app. And when we create it, this endpoint is not tied to the lifetime of any agent. There's no process running anywhere. This endpoint exists just purely in ngrok's cloud service, which means that this traffic policy, which is just the default one that's populated here, is something that you can update through the dashboard or via the API, and you can also delete this via the dashboard or API. If we go to this endpoint, you can see it says, hello, this is your new cloud endpoint, and has some text here. If we wanted to replace some of that text with something new, we might delete all of this content and say, hello, office hours, and save it. And when we come back here, give it a moment to update, you can see it says hello office hours. So these are cloud endpoints that are centrally managed, persistent, always online endpoints. They allow you to do things that you might have really simple asks for, like creating redirects, things like that. Small HTML pages, really easy to embed that content inside of these cloud endpoints. The other thing, and the place where they really become powerful here, is that you can wire cloud endpoints up to agent endpoints. And doing so requires us to introduce that last concept that we talked about earlier, which are internal endpoints. So I'm going to start a new endpoint here, which I'm going to call aws.internal. If we go back to our endpoints screen here, you can see that we now have two endpoints online. The one that we just created, which was in contribable.ngrok.app, you can see is an HTTPS endpoint. It is public, and it is cloud, right? Endpoints are either cloud or they are agent. And then they have what we call a binding, which is where they are available. And all of the endpoints that you are used to creating are public endpoints, and these new endpoints that end with .internal are internal endpoints. And internal endpoints are unroutable on the internet. They are not something that you can access. If you try to access them, you won't be able to, even if you like point your client at ngrok and ask for this name, we won't respond with any values for them. They exist only within the scope of your ngrok account. But what you can do is you can wire those pieces together. And the way that you do that is we have inside of traffic policy a new action that we call forward internal. And so this is a new traffic policy that says whenever I access incontrollable.ngrok.app, the traffic that comes in should then be forwarded to this internal endpoint. And that is the only way to actually get traffic to these internal endpoints. So if we go to this endpoint again, you should see that we start getting traffic again to our agent endpoint here. This creates a really, really flexible model where you can publish, essentially, like connect applications to ngrok without making them public, and allow you to separate out the logic that you use for how to handle traffic that does not have to be on the place where you are running the ngrok endpoint. It doesn't have to be on that container, that VM inside of that Kubernetes cluster, but can instead be centrally managed and controlled. The other interesting piece about this is that if we go and put debug equals 1, you'll see that we're still getting this debug response, which is very interesting because the traffic policy for incontrollable.ngrok.app does not actually have anything about that. But what you'll remember is that the traffic policy for aws.internal does have that. And what this is demonstrating is that you can essentially like that the traffic policies for each of these endpoints are composable. And that allows you to encapsulate logic about what does it mean for the traffic policy that needs to be on the public endpoint, the kind of like entry point or front door that is true for everything that you might want to forward to, and then isolate and encapsulate traffic policy for just the pieces that are perhaps the backends that you are forwarding to. Let's take a look at how we can start to look at routing here. Before we do that, I'm going to start another ngrok endpoint here. So we're still running these two, and I'm going to start up another one. A couple years ago, we introduced what we call ngrok agent SDKs. They allow you to take ngrok's functionality and bake them directly into your application itself. They are a way to essentially bundle the ngrok agent into a program. So we're going to look at a very simple Go program here that we are going to pretend is running on Azure, even though they are titled GCP. And what you can see here is this is a very simple Go program. If you're used to using or running Go, this is a very simple like hello world kind of server here. And in this hello world server, what we're saying here is we're going to listen and then respond to every HTTP request with hello from Azure. But interestingly, normally when you would write this hello world service in Go, you wouldn't call ngrok listen, you would call net.listen, and it would return to you a essentially a listener object, which is like a socket in most languages. And that listener object that is returned from getting a local port gets connections that you can then hand to the HTTP server. ngrok's agent SDK bundles all of that together and gives you a function call that returns to you an object that looks and feels like a listening socket, except that it is listening on ngrok's global cloud service. But it still looks and feels like a socket and can be plumbed into other things that accept a socket. We have support for these SDKs. I'm showing you an example in Go, but we have support for these SDKs in Python, in Java, in JavaScript, and in Rust as well. Let's run this application. So if we go over here, we can see this endpoint has come online, and if we access it, you'll see it says hello from Azure, which is showing essentially like, great, this application is running. But again, remember, we're not running the ngrok agent. It doesn't exist here. It's just the Go program, and all of that agent functionality has been baked into the program itself. This means that if you're distributing that program, you don't actually have to distribute an ngrok agent or figure out how to do that. It's in the library itself. Let's take a look at a slightly different version of this one here. This is that same program, but what we've done here with the program is we've changed two pieces of it. The first is we've changed the URL that it serves on to be azure.internal. And the second thing that we've changed here is that we've changed the traffic, we've added this traffic policy. And what this is showing you is that essentially the traffic policy system is agnostic to however you create endpoints with ngrok. You can create endpoints via the agent. You can create them with our agent SDKs. You can create them with cloud endpoints. The way that you configure how traffic is handled is the exact same across every way that you interact with the ngrok service. So let's save this and run it. Great, we're running. If we refresh our dashboard here, we can see that azure.internal is online, which means that if we wanted to change our traffic to point to Azure, we would simply click Save here after updating this URL. And then when we access our URL over here, you can see it says, oh, we didn't didn't update the text in this one here. Let's update that and say hello from Azure and put it back online. And now we're seeing hello from Azure. Exciting. We've shown how to move traffic from like one cloud service to another. But what if you wanted to be able to do that with just some automated, what if you wanted to do that in an automated way, like in a failover kind of way? And this is where these systems begin to combine in a really interesting way. We're going to update our traffic policy here. And instead of just forwarding to either AWS or Azure, we're going to forward to both. But what we're going to say here is that we're going to forward to AWS. But then if there's an error, we're going to continue on to the next action and then forward to Azure. And if there's an error there, then we're going to continue on and render a static response, which says no clouds available. So let's save that. And the one other thing that I want to impress upon you all that I forgot to mention is that when we specify these traffic policies, whether it's in this cloud endpoint or via the ngrok agent or even embedded via the SDK, it would be natural to imagine that this ngrok process is executing that traffic policy. That's not actually what's happening. When you start an endpoint, that traffic policy document is pushed to our global cloud service. Essentially, when you put an agent endpoint online, that traffic policy document and that endpoint is shipped to all of our global points of presence, servers running all around the world, and they instantly reconfigure themselves to accept the traffic on your behalf with the traffic policy document, which is executed at our global ngrok edge of our cloud service. The reason this matters is that it means that the execution of that policy is accelerated to a place that is closest to your customer or the client accessing the URL here. All right, so let's take a look at our demo here. If we go over here, we see that it says AWS, and that's great. But if we turn AWS off, we can see it says hello from Azure. And if we turn Azure off, we can see it says no clouds available. And putting AWS back online, we're back online. This is how simple and easy we've made it to automatically fail over between cloud services, to automatically route traffic between them, to easily switch where you're routing your traffic to. You could imagine, even though in this example we're showing like AWS and Azure, You could imagine doing this between regions like US East and US West if you needed to fail over between those two, or even different like countries, geographies, or potentially even different modes of hosting if you needed to fail over from like your cloud service to your on-prem services. Uh, in this traffic policy that we're looking at right now, we're always we will always go to AWS first and always go to Azure as the backup. But often when you have these things, when you have systems like this, you want to be able to express the ability to say like, I don't actually care that AWS is the default in this case, but I would like to force my traffic to go to Azure uh, if I want to. So I wanted to show you a traffic policy that would allow us to do that. So we're going to keep the exact same traffic policy that we have here. We're just going to add some new pieces in front of it that use the concept of conditionals that we were looking at earlier, those expressions. So I'm going to add in these two new pieces here. And what they say is there are two new rules in our traffic policy document. And what they say is, actually, please consult the query parameter, cloud, to determine where I should route traffic to. But if the cloud query parameter is not available, then we will use our regular routing rules about how to direct traffic. So let's save that and then go over we've got a lot of tabs going here and say, let's say Cloud Azure. And we do see it says hello from Azure. Or if we say cloud equals AWS, it says hello from AWS. Uh, Including if we turn AWS offline, you can see that it doesn't fail over anymore because we very explicitly asked, please take us to AWS. But if we remove that, you can see it says hello from Azure. So this is how you can use the traffic policy system to very flexibly direct traffic, not just based on whether something is up or not, but even use the variables to change how traffic is routed. That means you can change based on just the query parameters that we showed here, but all of those variables that we were looking at earlier, whether it happens to be cookies or TLS connection state or geography, if we wanted to route different countries to different cloud services or different regions, all of that is capable with this very simple system. Let's take a look at another one here. We're going to add one more action to our traffic policy system, or to our traffic policy document for this this particular endpoint here. And the thing that we're going to add kind of like brings together all the different things that we've been looking at. What it is it's a new traffic policy action that says we're going to route to a given URL, but the value that we're going to route to, we knew that we had AWS and Azure like up here. But what if we wanted to route to an endpoint that we don't know exists yet? Using the cell interpolation feature that we looked at previously to make those endpoints dynamic, to change, to show you like the user agent that was used when accessing the endpoint, we can just as well make where we route to dynamic based on a property in the request itself. So we're running AWS and Azure here, but what if we have a different endpoint? And I'm going to bring up another terminal to show you this. Here's another one where we just have a file that says we're debugging locally. And let's put that online with the URL local.internal. Or even like, you might imagine that this is something that's like my personal debugging piece here. And I want to route traffic to here. What this traffic policy allows me to do is to specify that URL that I want to route to in in the query variable itself. So let's say we route to Alan.internal, and now it says we're debugging locally. So we have successfully dynamically routed traffic based on just the query parameter that we have access to, without even knowing ahead of time that the Alan.internal endpoint was going to be online here. That's it for the demo. I'm gonna take a look. I haven't been looking at chat, and I'm sure there are many, many questions. I'm going to, before I answer questions, I'm going to go over just a little sneak peek of what's coming in 2025 beyond what I've showed you here already. So give me just a moment, and I'm gonna bring back up our presentation here.
Awesome. Yeah, we have a really great question from someone about these new primitives that you just showed off, internal endpoints, cloud endpoints, and like what are the implications of those for having to set up deploying multiple URLs or load balancers for different applications. And I think one of the things you're going to show is one of the ways that we're going to try to make load balancing even easier than like the way that you just showed it right now of using traffic policy. So like, yeah, what is the implication of these different routing strategies on like having to set up an AWS load balancer, or, GCP load balancer, everything like that?
Uh, yeah, I do want to talk about that. Before I do that, though, if we have enough time, there's one other piece of the demo that I want to get to. Maybe we don't have time to get to this, though. What do you think, Joel?
Yeah, I mean, it would be great to leave a couple minutes for some questions at the
Oh.
end, but if it's load balancing specific, then that would be very cool. Oh, you want to do Kubernetes stuff. That would also be cool.
Uh, we're probably not going to demo this in the interest of time, but what I do want to at least show to you all, and we'll see, maybe this will boot up in time to show everyone, is that this same way that we've created endpoints via agents, agent SDKs, and cloud endpoints, we also, as we mentioned, have a Kubernetes operator. This particular one is running inside of GitHub code spaces, which is still booting up. But if we get it to boot up, I'll show you that that's working as well. And when you use the ngrok Kubernetes operator, it is simply another way to create ngrok endpoints. So you can simply create ingress objects. We also have support for the gateway API. And then this example over here shows how you would create an ingress, but also, just like we said, that traffic policy system is completely flexible enough to work in every one of the ways that you interact with ngrok. The same applies here. You can essentially create an endpoint via creating an ingress object with a domain, which might be an internal endpoint we have here. And then via an annotation, here, attach a traffic policy, which uses the exact same traffic policy engine that we use for everything else here. Um, I think we might boot up just fast enough for me to show you.
Just fast enough. Yeah, I think we could almost have an entire separate 30-plus minute demo of the Kubernetes stuff, especially some of the most recent changes that are happening behind the scenes right now, that make what, yeah, used to be kind of where you'd have to manually manipulate like ingress objects or the gateway API, and these new these new things that you're showing here kind of abstract a lot of that away and allow you to just kind of create a ngrok ingress object, and it handles everything for you, which is very cool.
Yeah, it looks like we're running here. So
Okay.
let's create this ingress object here. We've created this cube cluster here. If you take a look at the pods, is basically showing, oh, well, we're gonna have to wait a little bit longer perhaps for these pods to be ready before this comes up. But we're just running a very simple like HTTP bin application for demonstration purposes. And what inside this cluster, we have the ngrok operator that has been installed, which is the piece that is interpreting these ingress objects and turning them into ngrok endpoints. Doesn't look like Codespaces is too particularly happy with me, so I don't think that this part of the demo is necessarily going to work. So we may come back another time, or after these pods get themselves running, we can maybe close with that. Instead, I'm going to take you back to our presentation here for a little bit of a roadmap sneak peek. These are things that we are working on, that we're actively working on and working towards delivering. I'm not going to give you any timelines or delivery dates on these, but we're trying to get them in front of you all as soon as possible. Um, the first is endpoint pools. And to our question about load balancing, this is really the feature that addresses that question. The next one of the things that we are working on delivering right now is this feature called endpoint pools. And the way it works is when you run two endpoints with the same URL, all of those endpoints automatically pool together. So if you create two endpoints that are named, incontrollable.ngrok.app, any requests, connections to them will be balanced among the two endpoints that share that URL. It doesn't matter if those endpoints are running in different cloud services. It doesn't matter if one of them is a cloud endpoint and another is an agent endpoint. They really could be distributed anywhere, and traffic will be balanced among them. Uh, that goes as well for internal endpoints. You can use them to create multiple endpoints that are called, Alan.internal, and it would balance between those as well. The other interesting piece about this that we're working towards is making sure that they are globally aware so that if you run the same endpoint or an endpoint with the same URL, one that's originating from a cloud region or service in Europe and another one that's originating from the United States, for example, that requests that come into our European points of presence will be prioritized and routed to the European instance of your application, that endpoint, and not necessarily like globally balanced instead. But within endpoints that are within the same region, that's where you will see the load balancing. So something that is smart and aware of the geography to keep your applications accelerated as well as balanced. Uh, and then this title is wrong, and I apologize about that. This should say Kubernetes bindings. Um, and what I've got here for Kubernetes bindings is another capability here that we're working on introducing, which is about adding secure, privately addressable endpoints. So the things that we showed today were public endpoints and internal endpoints. These are part of a concept that we call bindings. This new concept is the ability to create endpoints that do not appear publicly and are not necessarily internally scoped to the ngrok account, but instead, when you create this endpoint with this example down here, it will appear inside of Kubernetes clusters that you have installed the ngrok operator on, inside of the namespace, and with a name where I've got the word name here. So this allows you to essentially create like private connectivity between any Kubernetes clusters or between any real application and a Kubernetes cluster by essentially projecting a service into that cluster that can be addressed only within that service to receive traffic. There are other pieces that are coming soon, things like inside of your traffic policy, the ability to make an HTTP request, which may be useful to speak out to your APIs to get custom data to know like who authenticated first and pull in some data that you know about one of your users to make a decision in the traffic policy document based on something out of your own database or another API that you want to access. As well as a forward external action, which will allow you to forward to, right now, the things that you're seeing is the ability to forward to only other ngrok agents. Forward external will allow you to forward to other websites and public URLs on the internet. So if you wanted to use ngrok to disintermediate your traffic between, say, you and like a LLM service like OpenAI, um, or Perplexity or something like that, that you would essentially be able to use traffic policy to manipulate and change those requests before they are sent to an API and potentially merge or change those responses as they come back. Uh, I'm going to use the remaining 8 minutes for questions. Before I hop in there, the last thing that I want to mention is all the things that I demoed today are available. These are not sneak peeks. The things that you saw in the demo are available on our pay-as-you-go plan. So if you want to try them out or play with them, just grab one of those plans and you should be able to be off to the races.
Amazing. Thanks so much, Alan. Yeah, there's been a number of questions, and I think I'd like to start just as a transition out of the roadmap piece from a question that came from Leanne Miller at the very beginning of the session, which was, and specifically about like what is surprising to you about what you're planning for 2025? Like maybe of those five-ish things that you just talked about, or it's something else that you can't really get into too much detail yet, but like what is the thing that you kind of expected the least?
Uh, I I think the thing that's maybe most exciting and least expected is us creating those um, pieces around Kubernetes bindings and the additional types of endpoints that we are going to be able to create. Uh, I don't want to go too deep into it, but what I will say is the ability to put endpoints inside of another Kubernetes cluster to create private connectivity. The Kubernetes binding is the first of many additional bindings that you should expect to see out of ngrok. And so perhaps that's a unexpected and exciting next step for us here.
Yeah, and the bindings work is undergoing a lot of revision right now and polish to get it into a really nice state. And then hopefully, we'll be able to follow up really soon with a lot of new content, blog posts, docs, all of the stuff that I know people in the audience here like to dive into to figure out how they can adapt it for their own use case. We'll be able to follow up in the coming weeks or months with like a lot more information about how to use that for, like you said, private connecting private networks, site to site stuff, developer productivity against like remote clusters, a whole bunch of other stuff that is going to be really exciting. So yeah, that's amazing. There was another question from that somebody asked during registration that I thought was really interesting that plays into both what you demoed today and endpoint pools, which is how does ngrok let people shape traffic depending on, their use case or, like how do you send 10% of your traffic to one service or one version of your service, let's say on AWS, and then 90% to the same service on GCP? Obviously, we're not talking about like all of the other implications of being multi-cloud, but just that piece, or you could say canary deployments are a similar item. Like I don't know if you have something like a traffic policy ready to show, but or it could be more abstract, but I think that would be really interesting for a lot of people to know more about.
Yeah, I think what I will show you there is inside of, we're gonna do a quick screen share again. So once we deliver endpoint pools, there will be another interesting way to do this, but you can do things like that even today in the traffic policy system. Uh, nope, that's not the macro that I meant to have up here. Uh, do I have it? There it is. Within our traffic policy system, we do have macros that allow you to grab a random number. So if you want to change a conditional to say like, hey, if it's less than 5, essentially like, or 0.5 for 50% or 10%, that would be a really easy way to currently send 10% of your traffic to one URL and 90% to another endpoint. There are other ways that we expect to do this once we have our endpoint pooling feature delivered, but it is still something that's pretty easy to set up today.
Yeah, and if I have a minute to drop this into the chat before we wrap things up, I'll put a link to where that kind of using the random number is used. And it's funny that you started off by showing the time macro, because that was before the random stuff existed. I had come up with a workaround to use time and the number of milliseconds in a second to like route 50% of traffic to one place or another. But that's kind of I think that's what excites me the most about traffic policy, and what like to me was the coolest thing that was worked on in 2024 is like we have these common patterns, or like what we expect to be very common patterns in using traffic policy, but it's also a configuration language and it's very flexible, and you can come up with all sorts of interesting workarounds or just like ways to, mix and match all of these pieces to do things that me, Alan, product team, the engineers who built all this stuff did not necessarily think of as a viable use case. And that's very exciting.
Yeah, that's exactly right. We are very excited at ngrok to be building these pieces as a platform, which means that they are primitives that can be combined in interesting ways, ways that we may not have anticipated ourselves. But we build in this way because we know it creates the power and flexibility that you as ngrok developers need to express however you want to route your traffic. We could not imagine all of those things ahead of time, right? So we focus on building simple, reusable, composable primitives that you can combine in interesting ways to solve whatever custom problem you need to solve.
Exactly. That's yeah, and we'll be talking a lot more about composability in all of its different forms in the near future. But yeah, I mean, we are basically up to the hour here, so I just wanted to take a minute to, to thank you, Alan, for joining me today to go through all of this, to kind of just show everyone like what has been worked on. Like if people haven't been following our newsletter or reading all of our blog posts, I think it'd be very easy to like kind of miss the big picture. And I think this is a great way to kind of get people reoriented. And of course, to thank everybody for joining us, asking questions in the chat and the Q&A. Um, if you have technical questions about your accounts, you're not sure how to implement something, we have a phenomenal customer success team that you can reach out to them at support.ngrok.com. If you had a question and we didn't get to it, for one reason or another, like through the demo or, in our Q&A here, you can always email me and I'll kind of point you to the right person or the right resource that we have available. And you can also go into our community repo and add feature requests or bug reports or anything that you might come across. Our product team is in there to respond, and there's been things recently that have been introduced to, let's say, the agent CLI that were directly from user feedback there. So always happy to see those things. So with that, again, thanks everybody. Thank you, Alan, and we'll catch everybody next time.
Thank you all.